Welcome to my channel, Educational Wisdom, where learning meets clarity. Today we will discuss some important questions from Physics Past Paper Year 2025 Grade 9. Question 1. How many significant figures are there in 0.01023030? List the rules of significant figures applied on the number given part, I. Answer. 6 significant figures. 1. All numbers from 1 to 9 are significant figures. 2. In decimals, ending zeros are also significant figures. 3. Zeros between non-zero digits are significant figures. 4. Starting or leading zeros in decimals are not significant figures. Question 2. Describe the 3 states of equilibrium on the basis of center of gravity. 1. Stable equilibrium. When an object is slightly tilted from its original position, it comes back to its previous position due to rise in its center of gravity. 2. Unstable equilibrium. When an object is slightly tilted from its original position, it doesn't come back to its previous position due to change in its center of gravity. 3. Neutral equilibrium. When an object is slightly tilted from its original position, it gains new stable position but its center of gravity remains at the same height from ground. Question 3. Write any 3 differences between evaporation and boiling. Evaporation. Change of state from liquid to gas takes place without heating. Slow and calm process. Take place on the surface of liquid. Cause cooling effect. Boiling. Change of state from liquid to gas takes place on heating. Fast and noisy process. Take place in the entire body of liquid. Temperature remains constant. Question 4. A copper rod is 20 meters long with a cross-sectional area of 4 square meters. If its 2 ends are kept at temperatures 200 degrees Celsius and 300 degrees Celsius respectively, calculate the amount of heat flowing across the rod in 1 second. Note: take the coefficient of thermal conductivity as 386.4 J per meter. Ks. Solution: L equals 20 meters, A equals 4 square meters, initial temperature equals 200 degrees Celsius, final temperature equals 300 degrees Celsius, K equals 386.4 J, M. Ks. Increment Q, T equals K times A times increment T, L increment Q equals 386.4 times 4 times 300 degrees to 200 degrees, 20 increment Q equals 386.4 times 4 times 100 degrees, 20 increment Q equals 154,560 20th increment Q equals 7,728 J. Hence, the amount of heat flows across the rod in 1 second is 7,728 joules. Question 5. Zohan dropped a ball from a certain height. Its final velocity becomes 25 meters per second when it reaches the ground. Now from the same height, if he throws the ball vertically downward with an initial velocity of 25 meters per second, then calculate its final velocity. Note: take the value of acceleration due to gravity as 9.8 meters per square second. Data: final velocity equals 25 meters per second, initial velocity equals 0 meters per second. Acceleration due to gravity equals g equals 9.8 meters per square second. Height equals h equals. Solution: apply third equation of motion 2 atto Siemens equals Vf squared minus Vi squared, 2, 9.8, h equals 25 squared 0 to the power of 2, or 19.6 h equals 625, h equals 625 divided by 19.6 or h equals 31.88 meters. Question 5. Second part. Initial velocity equals 25 meters per second, final velocity equals, acceleration due to gravity equals g equals 9.8 meters per square second, height equals h equals 31.88 meters. Apply third equation of motion 2 atto Siemens equals Vf squared minus Vi squared 2, 9.8, 31.88, equals Vf squared 25 to the power of 2 624.8 equals Vf squared 625,624.8 plus 625 equals Vf squared 1249.8 equals Vf squared square root 1249.8 equals square root Vf squared. Vf equals 35.35 meters per second. Question 6. State and explain Newton's second law of motion and prove that the rate of change of momentum is equal to force. Statement: Newton's second law of motion states that when a net force acts on a body, an acceleration is produced in the body in the direction of applied force. The magnitude of acceleration is directly proportional to the magnitude of the force and inversely proportional to the mass of the body. Question 6. Second part. Relationship between force and momentum. Initial momentum equals pi equals m times v. Final momentum equals pf equals m times vf. Change in momentum equals increment p equals pf. Pi increment p equals mvf. mvi or increment p equals m. vf. v. Rate of change of momentum equals change in momentum, time increment p, t equals m. vf. v. t. Since acceleration equals a equals change in velocity, time increment p, t equals m times a, increment p, t equals f. According to Newton's second law, F equals ma. Hence, the rate of change of momentum of a body is equal to the applied force. Question 7. Sarah has mass of 30 kg. While running in the playground, she accelerates from 2 meters per second to 4 meters per second in 5s. Calculate the power consumed in the given situation. Data: mass equals m equals 30 kilograms, initial velocity equals v equals 2 meters per second, final velocity equals vf equals 4 meters per second, time taken equals t equals 5s, power equals p equals. Solution: acceleration equals 4 to 2, 5 equals 2 divided by 5 equals 0.4 meters per square second. Apply second equation of motion S equals v times t plus 1/2, a times t squared. S equals 2 times 5 plus 1/2, 0.4 times 5 squared, or S equals 10 plus 1/2, 0.4 times 25, or S equals 10 plus 1/2, 10, or S equals 10 plus 5 or S equals 15 meters. Force equals F equals m times A. F equals 30 times 0.4 or F equals 12 n. Work equals W equals force times displacement. W equals 12 times 15 or W equals 180 J. Power equals work divided by time. P equals 180 divided by 5. P equals 36 watts. Hence, power consumption is equal to 36 watts. Question 8. Explain why walls of a dam filled with water are usually wedge-shaped. Relate this with the pressure of liquid at different depths. Answer: the walls of dam are wedge-shaped to make flow of water easy. It is also because at the surface of water, there is low pressure, but as depth increases, the pressure of water starts increasing. That's why the walls are wedge-shaped. Question 9. If the density of water is 1000 kilograms per cubic meter, then calculate the depth of water in a dam when the pressure at the bottom is 1,000,000 pa. Note: take the value of acceleration due to gravity as 9.8 meters per square second. Data: density of water equals 1000 kilograms, m cubed, pressure at sea level equals 1,000,000 pa. Acceleration due to gravity equals g equals 9.8 meters per square second. Solution: pressure equals density times acceleration times depth, or P equals pgh, or H equals P divided by pg, or H equals 100,000 divided by 1000 times 9.8, or H equals 100,000 divided by 9,800, or depth equals 10.204 meters. Question 10. A stone of mass 100 grams is attached to a string is 1 meter long. The stone is rotating in a circle with a speed of 5 meters per second. Find the tension in the string. Data: mass equals m equals 100 grams equals 100 divided by 1000 equals 0.1 kilogram. Speed equals v equals 5 meters per second. Radius equals r equals 1 meter. Tension equals T equals. Solution: tension in string provides necessary centripetal force. T equals Fc equals mv squared divided by RT equals 0.1 times 5 squared divided by 1, or T equals 0.1 times 25, or T equals 2.5, and thus, tension in the string will be equal to 2.5 Newton. Thank you for watching. If you enjoyed this video, please like it, subscribe to the channel, and share it with others.